Hello, everybody. Good afternoon, and it's an honor and a privilege to be here with you and all the work that you're doing. Super inspiring for me, and leading us at Esri in some good directions. So it's been a bit for me. My last Cloud Native Geo Conference was during pandemic and totally virtual. So it's good to see some human beings here, and this breathtaking view is a little bit distracting as a speaker, but I also wanted to remind you, my colleague Noah Slocum will be in this room tomorrow at 11:45. He's going to cover more of the vector side of things, all the kinds of vectors and analysis at scale with geoanalytics. That'll be covering, among other things, our support for GeoParquet. So, from the imagery and remote sensing perspective, I'm going to focus on really what is imagery at Esri. It's a little bit mystifying sometimes, but I want to talk about that. And then really from there, what is imagery management? This is where a lot of our conversations lead back to from the beginning. Cloud storage access in ArcGIS supporting 2D and 3D experiences. All of these data formats and types that are being discussed at this event, and the data models that Esri provides to be able to load those by reference and control them at a greater scale and with greater efficiency. Definitely going to spend some time on Stack and some of the recent development that we've been doing around security and Stack support, and then a tool for generating Stack metadata called spatial asset management. So our typical customers, you guys probably realize that they are coming with a lot of data along for the ride already. So, it's not very common that we have a brand new user who just has fresh modern data that's ready to go. There is that, and most of the time we already have decades of data that's been on hand. Many times it hasn't been cloud optimized, and sometimes there is even decades of historic imagery that was scanned or sometimes collected digitally in the first place. But add to this the clear trend in the data volume and velocity that we see today, that everybody's talking about. More data is being collected all the time with more bands at greater resolution, at higher densities. And with this increase in the scale for analysis demand and kind of the perception that it should all happen sooner. And these sensors are capturing a wide array of data types. Like, 85% of our users want beautiful, fresh, true color imagery. They also work with multispectral, hyperspectral, LiDAR, radar, video, scientific data. And there's a lot that you can do with all these kinds of data sets. And there's even more that we can do with cloud computing now, with what's really been brought to the table with GeoAI. And so folks come to us typically pretty excited about things in the analysis section of our capabilities. Visualization's always important. More recently, reality mapping and reality capture for supporting modeling and digital twins and that kind of work. What happens, though, is that enthusiasm leads us back down to this foundation of data management and content, really. On the left, this ready-to-use imagery. We support that. It's not the topic of this discussion, but I want to mention the Living Atlas. In terms of spatial data, environments, and curated collections of data, this is coming from folks who are close to the data, the stewards, those who really understand it, its collection, its optimization, its whole lifetime. So beyond the content and the layers, there's also a ton of other types of data. There's models that are pre-trained for deep learning. including several bridges that let you just jump to include foundation vision models from Hugging Face. So very open, not the topic of my conversation today, here with you. So we're kind of reimagining this. These capability sets are the same, but really, when we talk about reality mapping, it is a huge content generator. And so are anything that you generate with analysis in our systems. And so there's really this connectedness to it all, that through visualization, deeper understanding, human insights, we conduct more informed analysis, we persist those results, and we want to be able to take those up into our catalogs, wherever they are. Our customers, it's important that we're meeting them where they're at. Some of them are still transitioning into cloud native operations, and so we importantly meet them where they're at. And so today I'm really focused on not our data and what we're providing, but our customers' data and those that are coming from content providers, partners that are delivering cloud native data as COG, as ZAR, with stack metadata alongside. So all of your imagery content, and this is something at Esri, I think it's just born out of the way we work together in this team of teams, the imagery team, the development and product teams. And imagery to us means a lot of things that it may not in this room or at this conference. So I want to point out, the many modalities of imagery at Esri. And just so that you're aware, sometimes when you're hearing a speaker or hearing some of our documentation, imagery is inclusive of things like point clouds. So it's an interesting take and something that I just like to point out in advance. And so I mentioned these conversations typically lead back to imagery management. And, why should we care about this? Honestly, our customers need help developing an imagery vision. They sometimes are pretty acutely aware of where they're at today, like what is the current state and the pain points around that. They also really need some help typically understanding their users and needs, or just taking a step back and looking at those use cases for each one of the personas. And sorry about that. Understanding the workflows, how people access the data. Is it through virtual system paths or HTTPS? And really understanding what type of services. Is it native ArcGIS sometimes? And also OGC. And really, we're helping develop that imagery vision for the organization. I always like to tell folks, too, that if you don't manage your imagery, it will ultimately manage you at some point. So these are the important questions in the beginning. Everybody's going to need to search and discover. We want there to be this concept of a common authority where we can look in one place and understand what the organization has and what it doesn't have. So if you're a content manager, maybe you're operating a fleet of drone equipment and pilots, creating content. You could be IT or an imagery asset manager, somebody that's procuring content and bringing it to the organization. So everybody's going to need to search and discover. And with the concept of management, sometimes it's a purchase or a collect or staging it up, just preparing it, ensuring that it's secured and described well and cataloged, and then serving it. And then certainly on the consumption side, we really want to be able to visualize, understand, and persist new insights as new content. And I see it all the time. The download use cases still persist. I think that often with some conversation around it, we can supplement that, but it's still something people need to take into the field, be disconnected, and so we support all of that. Another big reason is cost. So if you don't make your data known to the organization and you're kind of a silo, somebody may recapture it. They might buy the same data that's already been purchased from a partner. Also, duplication on your storage footprint. There are cases where it's necessary. A specific format or coordinate system reference may be necessary. And certainly if you're really going for this ideal optimized tile cache, there are use cases for it, but they should be well understood and agreed upon in the organization. Another one in terms of cost is networking. So the best practice is to co-locate your storage and your compute. It's fine for ad hoc understanding. We're able to reach into the planetary computer, for instance, from anywhere and start to visualize those data sets. But if you want to bring analysis at scale, we really need to pair that. And so I mention it again in performance. This consideration really relies on that pairing of your storage and your compute. And optimization, all right? So these cloud optimizations, whether it's raster or multidimensional or your 3D meshes and point clouds, it's really important for performance that you do that so that you're not having to download entire data sets just to understand them. So really, when we talk about imagery management, it comes down to these things. Organizations want to have some organization of their imagery with this optimization and efficiency in mind. They want to make it secure and accessible so that people can find what they're looking for. And so that those folks, those machines, those humans can visualize and analyze it. So this system really is one that has three fundamental types. There's this system of insight where we're doing analytics. We're gaining new information about the data, about the natural world or the built environment. And the system of engagement. These are all the tools that Esri puts into scope for dashboards, for low-code or no-code applications, web maps and web scenes, and all that kind of work that can expose this and engage others in your organization or your customers. And then the system of record, and this is really where the transactions are happening. This is what we mean by bringing imagery under management, so that it's part of that system of record and able to be fully exploited in this system. So the customers that we're talking to are really facing a lot of change many times. They're going through a digital transformation or having changes in their customers, their access patterns, budgets, workforce. They're interested in having greater scalability without term commitments, that the commercial cloud offers, and without having to make a huge investment on physical infrastructure. And sometimes it's just security compliance. So I mentioned this before, but we meet the customers where they're at. Some of them are used to direct access from a mission that they gather and collect. They need to be able to work with that. They also typically have some file servers. And so even if they're on this journey, or as they're on this journey to object storage, on-prem or commercial cloud, we're helping them engage along the way with all of that. We're helping them prioritize the highest value and most used data sets to get things cloud optimized, and really kind of taking some of the paralysis out of that. It's pretty daunting to look at, for instance, a terabyte or more of data and know that you've got to somehow not only optimize, but migrate it. And many of them are able to see the benefits from these open data sets being hosted by AWS, Microsoft, Google, and others that they don't have to carry. NAIP is one of those, the National Agricultural Imagery Program, where many different organizations are storing it. And so we're daylighting these connections for them as well. So this is a really important concept today. in terms of security and cloud storage access in ArcGIS. It's called an ACS, or an ArcGIS Cloud Storage Connection. This is one of the most versatile bridges to the content that I can describe. It enables us to provide different authorization scenarios for different providers. So all these on the left that you see, Azure, Amazon, Google, Alibaba, even your own on-prem object storage, and a new one called this web provider. This one is new in our upcoming release of 3.5, ArcGIS Pro. It allows us to apply parameters and then have this virtual browsing experience here, just as if it were part of your local data catalog. And the motivation around this web provider is really around token service vending endpoints. From folks like Azure and Carbon Mapper, Google, some of those OAuth providers. But it's very powerful. So each one of these gives you the ability to set parameters that are specific to that provider for authentication, for optimizations, and for even GDAL parameters. So GDAL is under the hood in ArcGIS. It's allowing us to set very specific access controls and methods around any virtual system access that we make. So it's very empowering. It can, of course, be automated, so we can create these ACS files. I'll show this later with some of the upcoming support around NASA Earth data catalogs. In Stack, they're all separately managed by security credentials. So rather than making those manually through the GUI, we just automate it. There's a counterpart to this ACS convention on the desktop for server. So if you need the server to be able to do that and access these data as it's streaming a service out, you create what's called a cloud store. It's the exact same conventions. You can do it through code or through REST or through a web user experience. And that just allows ArcGIS server to access that data that you've been authoring. Okay, so around security, a lot of our customers are kind of envisioning how they can meet their security needs and also the workflows that are just reality boots on the ground. And we see the idea of a parent organization operating in one region and meeting the needs of having that parity of the compute and the data. And we have child organizations that are they're the stewards. They're the ones closest to the natural environment where data is being collected, and they know and understand it. So one way that works really well is different regions where they operate as child orgs, managing that data in their own containers and in their own storage accounts. They, as part of this curation and content stewardship, organize, deduplicate. They look for that greatest harmony of versatility and optimization. And then when they're ready, they migrate that into the one region where everything can be managed, either in fully in blob containers. Some child orgs have a little bit of cloud native file serving services that they like to use. And then some customers really want to engage in a data lake. So this is a pretty Azure specific diagram, but representative of the kinds of security that people want to be able to accomplish and where we're helping them. Okay, and before I get into consuming all of this, I just wanted to mention in ArcGIS Pro now, there's a setting for authentication. This is where, as a user in Windows, you're able to authenticate against these authentication settings. So you can use Entra or a custom directory of users and groups, that are going to provide you role-based access control. In the case of Entra, we can use RBAC, we can use service principal, user-assigned managed identity, and custom scopes. So you're just in Windows, you're using an application, and it's granting you access to just what you're allowed to see in the cloud storage. You don't have to have all the separated authentication scenarios behind that. It just really simplifies a lot of the work. All right, so getting on to more about consumption. I'm just going to mention vector here for a moment. You know, we support CSV, GeoJSON, KML, GeoPackage, and OGC features. These are things that you can just reference from a file or from a URL and simply load them as items into a web map or into a portal. And it detects, you know, it tries to detect what it is and offer that type, or you can just manually set it and pull those into your maps. And now moving on into imagery. The way that these connections work is through this ACS file. So you'll see the beginning is a path to the ACS. It's typically local storage. And then it's one path, but it transitions into the object space. So you've got a fully qualified virtual system path that respects all of that authorization and authentication, or public. If you've got a public bucket, that's fine too. And you can use COG, you can use meta raster format, another open spec, or cloud raster format, which is one of Esri's. Just pull those into your maps and into your scenes. Or you can reference all of those paths in a data model like Mosaic dataset. And then you get to control all kinds of rendering rules and mosaicing rules on the fly. Here, you know, an entire statewide set of adjacent imagery being controlled by reference. So this is just a quick comparison. We typically just help our customers make this choice based on their needs. I'll typically qualify my bias in those conversations and sing the benefits of COG. I really like that it's one file, for example. But we help them understand, you know, the decisions that they're about to make before they dive into optimization. One of the notable things here is CRF allows a parallel write. So it is a cached structure. It's not one file, but that facilitates having many workers contributing to a massive production at the same time. On multidimensional data, we can read directly ZAR from these cloud storage connections, CRF, and more recently, I'm learning that HDF5 really is cloud optimized. So depending on how you make it. So this is a new one for me. I really didn't expect to see it perform like that, but really nice to see with some of the work that NASA has been doing on that front. And when we really don't yet have cloud optimized formats to work with, we help our customers understand the tooling that's available to them. So there's a geoprocessing tool called Copy Raster. It'll take as input any singular one of these data types and convert it to a cloud optimized format. You can have COG, you can use MRF, CRF, and ZAR and others. So this is a way that you can singularly manage that processing, or you can attach it and batch it. You can also, instead of taking singular rasters, you can have a set of related imagery that you convert through that Mosaic dataset model. So pretty convenient. And then we've got a fully open one that's leveraging GDAL. It's called Optimize Rasters, and it is fully scriptable. You can run it here like I'm demonstrating in the GUI, where you get the ability to just configure the source and the destination. They can be local or cloud on either side. And then you're configuring those parameters that you want for the compression through profiles. This is totally scriptable, and so you can just pick up those commands that are generated in the GUI and run those at scale on Linux, on serverless, however you want to do it. So that brings me to data models. And these are typically stored in a geodatabase. You can use DBMS-backed systems like PostgreSQL or cloud database flavors. And basically, or you can use file geodatabase. And you're storing a model that makes reference to these data sets. I've talked a bit about Mosaic dataset. It's kind of a hero in our ecosystem, very versatile. We also have one to support perspective imagery, things that are captured from an oblique nature or from motion video or from panoramas, and really impart all that context around the viewing angle, direction, and scale. Last data set is our point cloud model, where we can load individual point clouds and have that control, like we see with the Mosaic data set, over the whole thing. And trajectory data set, this is for things like laser altimetry, like the JEDI sensor on ISS. So heights on the Earth surface in linear measurements. And then there's other optimizations for climate study with voxels. We have all kinds of 3D mesh as a cloud-native format, I3S, and point cloud is also expressed in that format, I3S REST, multidimensional, and then tile cache. And one of the most important things here is that there's also a rich web model for REST services for every one of these, so that you can consume them as a service in REST and as OGC. Catalog dataset is a unique one, and I'm going to talk a little bit more about that. I'll show you some demonstrations. I'd say it's similar to Stack, but it's not the same thing. They're used for different purposes. Mosaic dataset, we author it by just referencing data in cloud stores or data stores. And it can be all kinds of different products from different platforms and sensor combinations. As you add the rasters, we recognize those types, formats, and metadata, and just make that part of the data model. And that gets defined in the metadata of the database. We also get to supply instructions about how to render. So these raster functions are super powerful. They allow us to use a library of system raster functions and to control how that rendering happens with one storage footprint. From the cloud, many different renderings. So it's pretty powerful. You can access these through, actually, this is not the slide. You can access these through the ribbon in the imagery group, and you have this kind of visual model builder way to construct the logic. You can make custom Python raster functions, so you're not even limited to the system set that we have. And these can be used a lot of time just on the fly. As you zoom and pan, the imagery is rendering as you've instructed. Or you can persist that out and save it as a new content raster. So very flexible, very powerful. All right, the catalog data set, this is a newer data model for us. It is intended to scrape metadata from files, like all of these different raster types, and then from point clouds, also from mesh and some of our data models, like the last data set, 3D mesh, and the multidimensional data. what we get is basically a feature class with all of that metadata and the ability to publish that as a service. We can also use the catalog dataset to index content from our portals and from our organizations. So where we have WebGIS operating, you can also generate a catalog dataset from there. So with that, let me just give you a quick demo here. Just want to switch screens. Maybe not so quick. Sorry about that. All right. So this is the result of creating a catalog data set from an ArcGIS Online organization. What it's done is generated bounding box geometry for every data set present. I can filter it with the map and by its type. I could look at just my feature services or only my OGC services, or everything. And then I can use time, like the date that it was published, from predefined periods, or from a custom time range. I can also take advantage of other data in this service, which is like the owner, just those things that maybe that I've published or curated in this environment, or those from everyone. And we can filter by size, by those that are public facing versus private, or even on their area of coverage. And no matter what the tools are we're using to filter, we're able to see the count of those, understanding those that are represented in each type, and understand what we have as an organization in certain geography. And oftentimes it's important to know what you don't have. We really don't have any content here in Salt Lake City based on these filters. So very powerful tool to help understand content. Go ahead and switch back. Oh, actually, let me show you another really interesting way you can use catalog data sets. We were looking at just the feature class and kind of filtering in a dashboard. One other thing that they do that's really unique is here's a set of LiDAR. We're able to see where, with these geometries in a scene, where they exist and understand their locations. But a catalog layer also lets you turn on those that are in view. And so it's automatically pulling them in based on what you have in context. So it's not just an understanding of, hey, we have stuff there, it's loading it. So that's just an option and part of the capabilities around catalog layer. All right. So moving on to Stack. This is, again, a relatively newer set of support for Esri. The first time I remember seeing it was in our APIs, in our ArcGIS API for Python. Soon after it came in ArcPy. And so I'm going to spend most of my time talking about Stack today around consuming Stack. It's where we have the richest support. But it's important to talk about creating Stack because you can have all these files, but as an organization who's really trying to get into the swing of cloud native and practice this authoritative place to search, they need help with this thing, this plus metadata. And this is the hard part, right, for a lot of our customers. We really, until recently, relied on just guiding them towards scripting and using low-level tools to harvest metadata. And I'll show you some tooling that we're getting ready to release that helps in this. But it's important. I think it's the hard part about Stack. GeoPortal Server is Esri's open source catalog. It has support for a lot of different metadata standards, OGC records, Inspire, and most recently, we added stack support to GeoPortal server. You can download it from GitHub, you can deploy it, and use that as a way to implement stack. So on the consuming side, this is really important to our customers. They seem to be increasingly knowing about the massive holdings of data that we're creating, we as a community. And they're interested in using it. And so it's really exciting to see them getting smarter about consuming stack, from the stack index, from the planetary computer, AWS open data, and all the rest. Our ArcGIS Pro user experience can consume it, so can the APIs. And so in a version ago, we had this stack connection enhancement. It actually emerged, I think, at 3.2, so it's been around for a couple of years. But at 3.3, we supported the static collection browsing. In this example, you're just seeing the planet open data, and because there's no search implemented, it's just a browse experience. You can browse through the different child collections and load those into your maps and scenes. At 3.4, we also made some enhancements for footprint visualization, just to help you make your decisions, whether that's static or dynamic. Connections to stack, you have this option now for each record, for each item, to show that footprint geometry on the map. It just helps in making the decision about your selections. In our next release, which is imminent, I think it's, I want to say in a matter of days here, these are some of the enhancements that you'll see. When you make a multiple selection, you're able to add those as a mosaic layer without even creating a mosaic data set. You can just throw them together. They land as a single layer on the map. And then you see here in the raster function here behind this, it's just organizing all of those into a mosaic. All right, and then with 3.5 release, we've also got some new stack APIs that we're supporting. NASA has been doing a fantastic job at these Earth data from each of the DACs. I want to say there's 12 of those, and they're all deployed in AWS in US West 2 in Oregon. So you essentially create an account, a free account with NASA, with Earth data, and then you create one of these cloud storage connections. You can connect to these and begin to search by place and time and pull in what you need. This is an example of the HDF formatting that I had mentioned earlier. Carbon Mapper is another one. The good work of Carbon Mapper in taking hyperspectral data, climate data, and producing higher order products as a consortium for the understanding of plume modeling and plumes measurement, looking at greenhouse gases in concentrations by just making a query of all of your sites of well pads or of electrical plants, consuming those higher order products or the lower level products, and conducting analysis about your operations. In our APIs, you'll see three methods, okay? So you can instantiate a raster object in the API for Python from a stack item, which is just a reference to the JSON, or from stack catalog, a static catalog. You can also create a raster collection, which is very much like a mosaic data set. It's just an in-memory model. And you can do that from a stack API query that you craft. At 3.4, we added these methods to ArcGIS. So for those folks that are working with files and needing to actually create a data model, they'll use those same capabilities, but inside of ArcGIS. And we also created a new class in ArcGIS, this ArcGIS input-output. This is really kind of abstract here, but I want to mention it because it lets us translate and abstract all these different virtual file system paths. If you have a handle on some cog in a VSI GS, you can easily just call for the HTTP version of that or the cloud store version and just easily begin to reflect what you need to conduct some analysis or automation. All right, so let me just take a minute and show what this looks like. Okay, so here in ArcGIS Pro, whoops, sorry. Here we go. So for a few versions now, you can go into the Insert tab of the main ribbon, and in Connections, just create a stack connection. And you can add one that's been created before or create a new one. And here you just need to give it a name. I'm going to use a really simple example, Microsoft Planetary Computer. This one happens to be built into the pick list here, and it doesn't require any authentication. As a stack API, it's open. But you can use that authentication mechanism that I had mentioned earlier with Pro, or you can pass custom headers for bearer token or other kind of basic authorization. And you can pass custom parameters as well if you need to do that on the API. On the data access, there's a separate tier. So if we want to access public data, there's no need for that. Here, Planetary Computer controls access with a token vending endpoint. It's headless. I don't have to have an account, but I do need to add those cloud storage connection files. So I just browse to their location. I have them downloaded here. And there's a lot of collections in Planetary Computer. So I can just add those that I know I want to work with. I tend to just add them all so that I can work with any data that I discover. And now in the stack group, I can simply right-click, explore stack. There's all the collections enumerated, and I can filter on those for whatever I'm interested in. I can see the assets that are being advertised by the stack. I can select certain assets if I want to, or just stick with the full set. I can filter by date and time. Let's head up Seattle and specify just the beginning, April Fool's Day through today. And my current display extent or that of a feature class that I'm wanting to use. I can filter on specific IDs or queryables that are being advertised. And in this case, that should be all I need to get the results back. The metadata that's coming along here comes directly from, I have to select the collection first. Okay. So the metadata comes along really quick, along with the thumbnail that just helps us make a decision about what we want to work with. I can fully inspect all the metadata. It's already here on my machine. Everything about that particular asset. I can view these geometries with the footprints button. That just loads a group layer with all the stack footprints that you're wanting to work with. So here I can see the coverage area. And if I want to, I can start dropping these into my map. I'll just go ahead and throw this one in. It'll pick that up and bring it, in this case, from Europe West region of Azure. As a cog, it's still reasonably performant. And again, I mentioned this as an ad hoc way to understand, maybe to fine tune a workflow. But if I was going to conduct analysis at scale, I would bring this I would just set my machine up in Azure in Europe West. And we have a marketplace listing that lets you do that. It's called ArcGIS for Microsoft Planetary Computer. All right, so now in addition to my stack results, in addition to my stack footprints, I've got a group layer that's going to catch all of the rasters that I add in an ad hoc way here. So here's that cog from that Sentinel scene. And you can also make multiple selections and add those to your Mosaic data set. All right. So I think I'm going to talk a bit, rather than this demo, I think I'll talk a little bit more about this spatial asset management. So this is a tool that will show up in that main ribbon inside of ArcGIS Pro. And really, it's coming in a site. I'll leave you the resource for it, called Imagery Management Workflows. It's our imagery workflows site. There's hundreds of these different specific workflows that help our customers navigate through all kinds of different modalities with sample data, instruction, videos, blogs, all kinds of resources. This will be one of those, and I'm just giving you a preview of it. But it's powered by Python scripts. It's just linked up to this tool group, and it allows us to create the concept of catalogs. There's 3 types: raster, point cloud, and oriented imagery. What it does is generates a feature class with footprint geometry and attributes that are just harvested from file metadata. We get everything that we need from low-level tooling like GDAL and PDAL inside of the ArcGIS environment. And we calculate some of the other values that are needed to describe a stack item and a stack collection. And then you have the power of ArcGIS at your fingertips to modify that, to symbolize it, to understand what format. Is it cloud optimized? That's part of the testing that we conduct. What's the pixel type and the spatial referencing system? All of these things that really go into a full description of stack metadata. And there's a tool in this group to be able to create the stack catalog. So once you're fine with the features that you've generated from a catalog that you've crawled, you can go in and dump the whole record set of stack. And then I've been using those, and as we're closing in on this, to consume that in ArcGIS. You can crawl data that's local on your system, or you can crawl through an ACS connection into a bucket. So it's pretty powerful. You can then use that metadata as a static stack catalog, like I'm showing here, browsing the items, or you can index it in your favorite stack compliant API. Here I'm using the implementation in GeoPortal Server. I don't think I mentioned that we implemented the transactions extension in that, so you can actually do your, add your collections just through a post. Or you can update them with a put. Same with the items. So I'd like to save some time for a discussion here. I think that's the majority of what I wanted to show. Actually, one more slide. Here's this imagery workflows site. When you land here, it's searchable based on topics, modality, workflow type. And you can come in and you'll get a listing of all these different cards that match your search. And you're going to get tons of information, tutorials and training, videos about each one of these. So it's a really great resource. Here's some of those resources. I'll make sure that these slides are available for the conference, and some other resources here around some of the modalities that I've talked about, the optimized rasters tooling, and some of the automation capabilities that we get out of this Mosaic dataset configuration script. So yeah, with that, wonder if there's any questions in the audience.
Quick question for the Sentinel-2 example you show where you added it to the map. Are you then able to download or I guess export it locally? Do you know? And if you can, does that come down as a mosaic single like a GeoTIFF or whatever you save it as, or each individual band as you would maybe from if you downloaded it from kind of the source site?
It's a really great question. Let me just show some options here. The method that I chose there to add to map, it takes 4 bands, the highest resolution bands. That's just the rule we have with that particular raster type. And so what I have in my map right here is a 4-band 10-meter data set. That's the RGB near infrared. But that's only because I took that shortcut. I can get all the bands. And to answer your question, I could right now export. I could just do a copy raster, export raster if I want to do that. There's another way though, with that ACS connection. There's another tool here. If really I just want to download a granule of Sentinel completely, you can find a tool called transfer files. And it's a really simple looking tool. Input path or paths using ACS to a cloud object store. And you can apply a filter to say, hey, I only need these file extensions from there, or you can just take everything and you can copy that out to a local destination. Okay. Thank you very much for joining me.
Thank you.